Okay, so I'm just going to add here. The period is 360, so it has not changed. The normal period of a sine graph is 360 degrees. I'm sorry, that's frozen. The normal period of a sine graph is 360, so if it's still 360, then your K value will always be 1. Okay, if it's changed, then we need to figure out what K is. We'll look now at some more examples. Are there any questions on this first one, guys? All right, let's look at G and H. Now remember these are questions from the textbook, so you will be able to find the diagram there. Okay, let's look at G. G is this graph here. No, just taking this off. Oh dear, that's not gonna help. Okay, guys, so we're looking at graph G, which is that big one. What do we think? Is that a triangle or polygon? It could be either, right? It's actually, let's say, where is almost like a middle value here. This one is a bit difficult to do because it's very stretched out. You see that? We don't actually even have a full curve of this one, right? If we're looking at F, that one was easier to do because we have a couple of curves. You can see nicely what the shape is. This is not a tan graph. A tan graph would go like that, right? And up like that. That would be the shape of the graph. This is actually a sine graph with a very big period that we can't even see on our diagram, right? So are we okay with saying that that is the starting point of this graph? Remember, sine graph starts at the origin usually, goes up to 1, to 0, down to -1, back to 0. Okay, so I'm going to actually just plot that one there. That is the starting point. So guys, we can say it's still starting at 0, 0, it doesn't actually show. Right, is that fine? Still at 0, 0. The previous one was supposed to be at 0, 0, but it was at 50. Okay, so that's why we say that the previous one. This one is at the origin. Okay, so I'm going to write that down for G. The starting point at 0, 0, therefore has not moved to the left or right. Now, when you're doing this in an exam or in a test, you don't have to write this down, but it is useful to have it in the example that you do, so that you know exactly where it's coming from. Guys, if it hasn't moved to the left or the right, we're not going to have an x minus p. Right, that bracket, we're not going to have a bracket. It's actually just going to be x. So we're going to have something that looks like this. Y is equal to a sine kx plus q. Right, we only have a bracket, an x minus p bracket, if the graph moves to the left or the right. Okay, in this case, still starting at 0, 0, so it hasn't moved. Okay, let's see if we can identify the A value, the amplitude. First, we need to see, is the direction up or down? So that's going to tell us if it's up, it's positive. If it's down, it's negative. Okay, let's look at the graph. We're looking at G. So from the starting point, that's what we look at, right? So we see that it is going up. Okay, so that the direction is the correct direction, it's going upwards. So our A value is positive. And write that down. Okay, but apart from that, we actually need to calculate the A value. Remember, the formula is maximum value minus minimum value divided by 2. So let's look at the graph. I'll come back to that now. Now, guys, they do at least have to give you enough information to see what the maximum and the minimum value is. Okay, so we can see here the maximum value looks like it's 1 over there, right? They're telling us that that's 360 and 1. And the minimum value is negative 360 and negative 1. Okay, So the A value is going to be 1 minus -1 over 2, that's the numerical amplitude. Now remember, minus becomes a plus, so this is actually 1 plus 1, which is 2, and 2 divided by 2 is 1. Okay, so the A value for this graph is this one. Okay, so we know that the equation is going to be something like this. Y equals 1 sine, we don't have to write that one, kx plus u. Okay, so we are going one thing at a time, guys. Some of these values, once you practice a few of them, you will be able to see them quite easily. You maybe don't have to write all of that down, okay? But for the beginning, for the first couple of ones, let's write it down properly so we know exactly what to do. Okay, now we can look for K next, but K is actually a bit more complicated. So let's quickly look for Q. Remember, Q is up or down. Okay, so we need to see, is the middle value actually in the middle between our starting and ending, our maximum and minimum value? Does it look to you guys like this graph has moved up or down? Okay, if it's going from -1, then our middle value is 0 and it's going to +1, right? It hasn't actually moved up or down. Okay, if we went maybe from 0 to 2 and then back to 0, then it would have moved up. Okay, so if the maximum and the minimum values are like on either side of 0, for example, up or down. So if it didn't move up or down, the Q value is 0. There's no Q. Okay, it didn't show. I'm just going to write that next. Didn't move up or down. Therefore, Q is 0. So that is telling us even more about this equation. We're going to have just sine kx, right? Because Q now is 0. So y equals sine kx. Now we need to find k. Now guys, what we need to remember is that we actually have this formula, which I'm not sure if we have written it down specifically, but we know that the period, because we wrote it down as like a little 5 calculation. The period is, if we're talking about a sine graph, 360 divided by k. Right? That's how we normally get the period, right? You guys agree? If there is a k value, it doesn't have in front of it. Then we say we're taking the original period, the normal period, which is 360 cosine, and we're dividing it by that k. So guys, now we want to find k. So what we're going to do is we're going to figure out what the period of the graph is, right? And put it here in the place of period. We're going to write that value, and then we're going to solve for k. All right, like it's an equation that we're solving for x, but now we're just solving for k. But now I need to look at the graph, and this one is a bit difficult to see, all right? But from the graph, from the information that they've given us, we need to figure out what is the period of this graph. Now guys, like I said before, they didn't even give us a full curve, right? Do you guys see that they've actually given us half a curve? Does that make sense? Right, from, let's say, from -1 all the way up and then all the way back down to -1, that would be one full curve. So we can't see the full curve on this graph, but what we can see is that this is half the curve. In what? How many degrees is that? If we're going from -360 all the way to +360, that's actually 720 degrees. That's only half the curve. So how many degrees will give me one full curve? I will have to double this, hey? Not 720 doubled times 2. 440, good. All right, so the period of this graph, even though we can't see it, we need to see that we actually have half a curve in 720 degrees. So the full curve is going to be 1,440 degrees. I will write a little note on that now, on where we're actually getting that from. So we have half a curve in 720. So one curve will be 1, 4, 40. Okay, that's where we're getting that from. But that's difficult to see, guys. That's quite a tricky one. I'm sorry, over K, hey? Well, I wrote these as well. Okay, the period is 360 over K. So this is the formula that you need to remember, guys. You're actually going to use this as a formula to find K, all right? The normal period of your graph divided by whatever the K value is. Now, how am I going to solve the K now? It's in the denominator. What do I have to do? Times it out, okay? What's the opposite of dividing by K? Times by K. All right, so I'm going to have 1, 4, 40 times K equal to 360 degrees. How do I get K on its own? What do I do with that 1, 4, 40? And to divide on the other side, hey? I need to say 360 divided by 1, 4, 40. I'm running out of space, so I'm just going to do it on the side here. So K is 360 over 1, 4, 40, which you can type into the calculator, and I think that's a quarter. Oh, thank you. So K is actually a quarter, guys. 1 over 4. So what is my equation? Y is equal to sine 1 over 4 x. Okay, you can just write that down so that I'm just that is the equation of g. You can write it as y equals, or you can use function notation. You can say g of x is equal to sine of quarter x. Just add that in. I think we wrote x as f of x. Okay, so we'll write that one as g of x on at the bottom. Okay, any questions on this one? So this was quite tricky, guys, identifying that period because you couldn't actually see it on the graph. Okay, but if you can see that it's half a curve, then you just need to double that bit that you can see, that 700. All right, are there any questions on this one? Now, guys, the next one, let me just see what is the next one. How difficult is the next one? The next one is H, which I will just highlight for you guys quickly. And I think, let me see, where is H? H is this green one. Okay. I'm going to ask you guys to do H on your own. See if you can come up with an answer to H. You want to see your just tips and see if we can find it. Please, thank you. If not, we'll make another plan. Okay, guys, there we go. That's the one that you that you need to find the equation for quickly. Can we all agree that that's a cos graph? But the cos graph normally starts at the highest value. This one is starting at the lowest value. What effect is that going to have on the equation? Your A value is going to be negative. Okay, that is why, that is what's gonna make it start at the bottom, at the lowest value. So this point here. Normally a cos graph starts at the highest value. Okay, see if you can find the rest of that equation. Now, I've already told you that A is a negative number, but you must figure out what number it actually is. Okay, so do that one quickly on your own. Thank you, Shane, thank you. What did it just fall? Did you guys not select it? Typical time. Okay, guys, we just take a look. Right, that's what I got. Anyone else? So your A value is actually -1/2 now, all right? So I just, like we did in Thursday's example, maybe you forgot, but because we saw from the start that our A value is going to be negative, when we actually use the formula, we put the minus in already. Okay, so just add that in if you forgot that. So then you take your highest value minus your lowest value. So that is actually 1/2 plus 1/2, right? Which is actually 1/2, which is then -1/2. So that's your A value. Again, for the period, I use this formula. Okay, so the cos graph, guys, the period of or the normal period of a cos graph is 360. So we're going to say that the period is again 360 over k. So you look at your graph now, guys, they actually gave us one full curve, but it was from -360 to +360. Okay, so the period here was 720. I just want to go up to the picture just to show you again how we see that. Right, so I know that this starting point is technically of the cos graph, but we can't see a full curve from there. Okay, so you can look from the start of your actual domain of your x-axis at -360. What value do we have there? 1/2, right? You can read that all day. So from there, one full curve would be all the way down to the lowest point and then all the way back up to that highest point. Okay, that is one full curve. All right, so that is from -360 to 720 degrees is the period of that one. So I just use that formula again. The period is 720 now, so I put that in the place of period here. That is equal to 360 over k. You move the k over to the other side, like we just did. And then to get k on, it's only going to have to say 360 over 720. Okay, you need to take 360 and divide it by 720. So the k value then is 1/2. And then you need to actually write the final answer with the A value and the K value in that equation. If you agree, guys, that this graph didn't shift up or down, right? It went from -1/2 to +1/2. So it didn't shift up or down. It also didn't shift to the side. Okay, because yeah, you can see that the starting point was still on the axis. Yes.
I'm taking calculation. What is your negative?
For this one here, it's because it starts at the lowest point instead of the highest point. The cos graph normally starts at 1 and then it goes down. This one starts at the lowest point. Oh, sorry. There, that's the starting point. So always look at the point on the y-axis. If it was a positive A, it would have started there and gone down the other way around. Okay, so that's how we did that. Right, any other questions, guys? Okay, I know we haven't had time yet. I don't want to do that yet. I want you to do from exercise 8, the same exercise. I'll just put it on the board for you again. All right, so this is still exercise 8, but now we are looking at number 2. I'll show you now on the graph. Again, I just want you to find the equations of the two sine or cos graphs. Right, so it's the same exercise, exercise 8 on page 130. All right, you can see they're asking all that questions. There are 3 graphs here, but we haven't spoken about tan graphs yet, guys. I would like you to find the equation of F, which is that purple graph there, and then the equation of G, which is that graph over there. Now, guys, we're just looking at G. Sorry, it's not very clear there. But do you see that this is definitely a graph that has been shifted up? right? It's not even going below the x-axis. That's very unusual. The only way for that to happen is if you have a graph that has shifted up. Okay, so see if you can figure out how many units has this graph actually shifted up. All right, I would like you to find the equation of x and of g. You can't see on the board there. It's on page 150 in the textbook. Maybe let's see if we close some curtains there. Yes. Okay. We find the equation of x and of g. And it's not a homework, guys. We're going to talk about it now in class. So please, everyone, good. And Chris on that side. We're looking at the highlight. Yes, just